welcome to Ladyada.
Hey everybody, and happy Mother's Day to everybody out there who has a mother, which is most of us. So don't forget to call your mom. All right, we're at my desk, and thanks to everyone who is back. Last week we were doing a whole bunch of stuff. This week we're doing another stream, so we'll catch up on like 2 weeks worth of Tronics that we're working on. So let's go to maybe we'll do the first things first, huh? Let's go to the overhead. Okay. So I've been going through a whole bunch of redesigns of stuff, and one of the things I've been working on redesigning is this soil sensor. So this uses the SMT 10, and this is before we started making STEMMA QT boards. So this has the old 2 mm pitch JST connector, a SMT 10. Because it's a SMT 10 ARM core chip, for it to run on 5 volts, it needs a 3-volt regulator here and then a 3.3-volt level shifter. And the way it does the soil sensing is this part is one big copper plate that goes into the soil, and then I would use the free touch, the SMT 10, the SMT series internal capacitive touch sensor, which we reverse engineered on the desk of Ladyada like 7 years ago or whatever. And this works okay, but it's a little non-linear, and like people have been like, oh, I wish it was like a little bit more linear, because it would basically like detect detect the capacitance. The range of the capacitance wasn't very high, and so you would basically have like a very high reading until it was completely dry, and then it would turn off, which would be better if it was like a more gradual descent as the soil got less wet. And so I wanted to revise this also to not use the SMT 10 anymore, because although we have quite a few in stock right now, honestly we I want to move to the AT Tiny series because it's less expensive. You don't need a 3-volt regulator because it's a 3 or 5-volt part. I also wanted to convert this to STEMMA QT so it was trainable, and maybe add, this a slightly different capacitive sensing method. So here's what I came up with. Go to the computer. So this is my new version that I just sent out PCB, so I don't have the final design yet, but you can kind of get a sense of what's going on. So there's got 2 STEMMA QT ports over here, and then we're using an AT Tiny 816, which we stock. We have a breakout board for it. It's a very small 8-bit micro, but we have seesaw ported to it. I have a little NeoPixel, because I thought that'd be kind of neat to have it, like maybe you'd be able to, if you had multiple sensors, you could set the NeoPixel of the one that's dry to be red, so like that one needs to be watered, or give you like instant feedback. I also added an AHT20. It's like a low-cost temperature humidity sensor, because like, oh well, if you're here anyways, and I don't have to have a regulator. Like the regulator and level shifter that I save is it's like 20 cents. In exchange, I'll pop down this temperature and humidity I2C sensor. They're not like great quality sensors. They're not like an SHT45, but they're also 20 cents. So it'll give you like, not only will you get a soil moisture sensing, but you'll get a the ambient air humidity and temperature. Just capacitors, pull up on the reset line, an activity LED, just a red LED. And then this is how the sensor works. And so instead of using, there is actually a capacitive touch peripheral inside the AT Tiny, but we're not using it. Instead, we're doing like manually, sort of like a non-built-in capacitive touch sensing. We're doing capacitive sensing by having an excite pin, which will, charge up the voltage on this 1 mega ohm resistor, and then the sensor will read how long it takes for it to charge or discharge. I mean, usually symmetric. So a nice thing is, first off, this can be low usually, and so there's no DC current across the soil because it's probably not great for plants. Not that it's like DC, but it's like, you'll have less AC signal. And then second, we can change the dynamic. We have a much wider dynamic range because the capacitive touch sensor elements, they'll time out and eventually, where with this, it can be like seconds, microseconds, nanoseconds. We can do, a wide range of timing. And I can change this resistor as well to account for like basically what the capacitance of soil is. And then on the other side, to make the other end of the capacitor, we have like a ground plane, which is indicated here by this touch point. And then to set the address, which I thought would be interesting, is I'm trying again to make things easier and easier on people. And I had this idea when I was looking at these Pico boards, and let me see if I can find one that has. Now this one is going to, I'll find one that has multiple. So what I thought was kind of neat is there was one of these, oh yeah. So this temperature sensor, and to do the address selection, they have like a dip switch, but it's like really tiny. And that's when I realized, because I really did not know, there exist dip switches with 0.05, 1.27 millimeter pitch spacing. And I was like, oh, this is great because, they're not too expensive. We'll show it on the Great Search. Oh wait, this is the wrong board. There you go. And I can have a 3 address select in the center here, and then people can have multiple. Because I thought, like, if you're gonna have a soil sensor, you might have multiple plants, and you could chain them together, and then you just flip the switch on each one. It might be easier than like cutting and soldering a trace. This is like really solder free. So you can see here that capacitor made by the 2 big plates, and then we have a little gap in between to make sure that we're not measuring the capacitance across here. We want the capacitance across the damp soil that will be touching both these plates. And these plates can be covered with, because it's capacitive, they can be covered with mask. So they're not exposed and they won't oxidize. I mean, they're gold, but they won't even like get dirty. Basically, you can wipe them down. Here is the AT Tiny. This is that 1 mega ohm resistor LED, a tiny little NeoPixel, temperature and humidity sensor. Although I might move this up if I can. I don't know, maybe I'll shift this up so it's not as close to the dirt. 2 holes. I mean, I could put like 2 little toothpicks through this, and so it could sit on top of the soil so it doesn't sink down. And then 2 stemma QT pins as well. So that's this, so I was like, okay, we'll try this. Carter has been writing the firmware code. He just added a PR to add, basically the seesaw code to support this kind of new capacitive sensing. So I think should like just work. And then the HT20 is connected through as well. I'll probably make a version without. It'll be a little bit less expensive. And also, again, that would conflict on the I2C port. So it's the HT sensor I'm still, thinking about. And then I was like, oh, I wanted to make a Trinky version. And then, okay, crashed. Okay, here you go. So this is a version very similar, but it has an SMT D21E18 instead of an AT Tiny. So this is actually like, fully microcontroller programmable over USB. And here's a USB-C port. And then I added a light sensor over here, a NeoPixel, temperature and humidity sensor, nice high up with a cutout, so it isolates a little bit from the microcontroller. That same, capacitive 2 plates system with, the timing. And then these holes are on like a stemma QT 1 by 0.7 inch boundary. So you could, with this stemma port over here, you could actually, if you want like like an air quality sensor, you could like stack it on top and then like screw it on to make like kind of an all-in-one. I wanted to make like all-in-one plant care, like hydroponic or agricultural or green thumb. It's kind of what I'm calling it. Sensor. So like I said, you have light, temperature, humidity, soil moisture, a NeoPixel, and then of course you can add other sensors if you want. So this will be like a Trinky, not really a Trinky. I don't know what I was going to call this. It's like a little dev board that I think, it'll work best in Arduino, but I think it might work in CircuitPython just for simple measurement and data capture. And it'll probably come pre-programmed and just give you those values out as a CSV. So you could like immediately get some, plant projects going. I think a lot of students and kids, they start doing, you know, a plant project pretty early. Another thing is, I had a lot of requests. Like we look at the searches on, here's basic. I look at the searches on the Adafruit site, and I noticed a lot of people searching for HX711. And that's a what's it called? Strain gauge sensor element. So strain gauge looks like this. So you need like a 24-bit ADC, but it doesn't have to be very fast. And so historically, we still sell the NAU 7802, which I like because it's I2C, and so you can just plug and play, and then you screw in. Now it even comes with terminal blocks pre-attached. You screw in your 4-wire sensor, and then the strain gauge, you can immediately start reading data. But I think if you have multiple, because it doesn't have a changeable address, and maybe you want multiple sensors, or maybe like you're using code that already uses the HX711. I don't know, but basically we just have a lot of people asking us for it. So I made a design for the HX11. So it's not quite SPI, it's SPI-like. It has data and clock. And one of the cool things about open source hardware is I was like, where do I start with this? I downloaded the data sheet, and usually the data sheet has like a lot of details on like how you would wire it up, and like, you know, like inductor, capacitor here, resistor, what value. But the data sheet was actually like kind of lame. And so I actually ended up basing this design off of the SparkFun HX711 breakout, because like they've already done multiple revisions and learned a lot and gotten feedback from the community. And then I made a couple other changes to it. So you know, this part, you know, these values are kind of from the data sheet, but SparkFun's design added a inductor onto the VPP line, I guess, to, you know, make it a little bit quieter. So there's an LC filter here. And then the things that I changed, what did I change? Yes, it's based on their load cell. I broke out both. Oh wait, I made a mistake. This should be tied to ground. Uh-oh. Oh well, I'll have to fix that on the prototype board. I bring out both. There's two bridges readers. So there's the A bridge and the B bridge. So I brought out both bridges because I'm using a 2.54, 0.1 inch pitch connector. Although you see here, I forgot to connect the ground, so I'll have to fix that. And then for the rate, I have a little slide switch. I'll show it on the TW. So you can select high or low rate. The higher rate, of course, you can read data faster, but it's noisier than the low rate, which I think probably just some oversampling. So already found a mistake, gonna fix that. Maybe in the next revision, I'll order another PCB. I'll probably just like, patch it at first. There you go, bink. That's the ground. So see, sometimes it's good to do a live stream show because you find mistakes live. Okay, how are we doing on time, Mr. Ladyada? Okay, great. So let's go to the, oh wait, one more thing real fast. And then we'll go to the great search. Breakout USB. So the last one is this funky chip. Some folks emailed us about actually a long time ago, and then during the part shortage, I couldn't finish it. This is, oops. This is the CH9328 from WCH. They make like all sorts of cool, wacky stuff. So this is a cool chip that has UART input and then acts as a keyboard. So you can actually send it like ASCII characters, and it will type them as if you type them in. I thought this could be cool for like assistive technology. I have to remember, it's not accessibility technology, it's assistive technology. My brain uses words wrong sometimes. So for if you're like, you want to make an ESP32 act like a keyboard and it doesn't have native USB, this will act like a keyboard, but you can send the reports or ASCII characters. And there's a lot of different modes because it's like whether you want to send ASCII or reports or whatever. And so again, I'm using that 0.05, 1.27 millimeter pitch dip switch to select the mode, because that way you don't have to cut jump resistors or use jumpers. Okay, so speaking of which, let's go to the great search. Where in the world
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses the power of engineering to help you find all things you want on digikey.com. What is the Great Search of the week this week?
Okay, so this week, hold on. Show layers. Wait, cancel. Sorry. So let's go to my computer. Oh, can we go to the computer?
Oh, yeah.
Okay. Okay, so this week, I'm working on a bunch of boards, and a lot of them have modes or configuration bits that you want to set. Like the CH9328 is a UART to USB HID chip, and it has 4 I/O pins that you can select different modes. So, like one mode is when it gets ASCII characters, the ASCII characters are typed by the keyboard, and there's another mode where you send hex characters instead. And normally what I would do is have little jumpers or something, and you would cut or solder the jumpers, or you could use through-hole jumpers. So another thing is max 98. So on like this audio amplifier board, I use, it's hard to see here. I use, you can select a gain. I use a 2x4 male header connector, and then a little jumper, a little, little handle jumper, and you plug it into what gain you want, 9, 12, 15, 18. The problem is a lot of people lose the jumper. I mean, this is very inexpensive, and it can pass high current. But if you're not passing high current, like if you're using it for selection, not for like power manipulation, you only have to pass like a milliamp or 10. People lose this like gets bent. People, accidentally maybe put 2, or I don't know, it's confusing. And of course it's kind of tall. If you want something slimmer, a dip switch is the way to go. And we use dip switch on, I think, audio amp. Let me see which one it was. It was like the TPA. Oops, TPS. Second. Sorry, I can't type. Here you go. So on the TPA 211, to set the gain, this is like a later design. I was like, oh, I'm going to use a dip switch. And so you can set the 2 bits of the gain by flipping the switch. And what's nice is you don't lose the little handle. It's a lot slimmer. So you can see it doesn't rise up more than like a couple millimeters. Of course you can set both at the same time. That's the only thing, is make sure that your design doesn't break if people flip 2 switches at once. So I prefer these now. I mean, this is a newer design. But for this board, the issue is I wanted to keep it nice and compact. And so I was looking at a temperature sensor from Core Electronics, and I saw like, oh, they have a really compact dip switch to select the address. And I was like, ooh, I didn't know these existed. I thought that dip switches only came in this, 0.1 inch, 2.54 millimeter pitch. So I went on a search at DigiKey, because they have everything. So I was like, I bet they have these fine pitch dip switches. So first you look for dip switch, and you see you have dip switches. Although this is like a dip switch, not dip switches. Usually you want more than one. And as usual, let's only look for active. I only want stuff to be in stock, and I only want surface mount. Through hole is, very popular, but this is like a through hole style. But I want a surface mount because I want to pick and place it, and I want it to be in stock also. So really narrow it down. Next, the number of positions I want specifically in this case is 4, because there were 4 GPIOs on this CH9328 to select. So let's do 4 position. And then, again, the pitch is, the current doesn't matter, because like I said, this is a 3-volt chip, so I don't need a voltage rating that's high. I don't need a current rating that's high. But I do want a pitch, so I want half pitch. So I'm going to select 1.27, although it looks like they even get thinner. But I think more than half is going to be tough for people to switch mechanically. Okay, so now we're down to 38 options, which is great. So let's look at some of these options. These look really good. You know, some of them have the pads underneath. You know, you're even smaller. These are cute. There's the piano style, which is, you know, adorable, like a little piano switch, but that's going to be, I think, more than, I mean, I think I'm going to go with this style. And I kind of like the J leg a little bit more than the underneath. I feel like it would be more, I mean, it's probably not technically more mechanically stable, but it feels like it would be. So let's get rid of the piano style. So let's do slide. And I think like that's, you know, 30 entries. Okay, that's a pretty good amount. So then, you know, I'm going to want, oh, they moved this down. So, you know, I'm probably going to want like about 500 at a time. Oh, another thing is I want it to be in tape and reel or cut tape. I don't want tube or bulk because I want to be able to pick and place it on the pick and place machine. So I'm going to get rid of the tube packaging because a lot of times they're available in both. And we do have what's called a tube jiggler on the pick and place, but it's like kind of flaky, and like tape is much, much better. So let's only search for tape. And then let's just look at the least expensive. So it looks like a couple options here. This one, one from CUI. You know, this one looks like a little bit nicer, but it's a little bit more expensive. Like this one, I like how it has that little under dip. So it kind of depends. If you're willing to spend a little bit more money, you can go for the CUI ones. They're like very reliable and known. And like I said, I like the J leg. I don't like this style. But if you're just going for like pure cost, this one's going to be the least expensive at like 70 cents per quantity. It looks like it's a little bit recessed. So like, you know, people will need to use like the point of a pen to get to it. But you know, I've used the CTS series ones and they're very reliable. So this is the 218 4LP, so low profile. It's sealed with top tape, which is good, and then in real packaging. So this is my pick. You know, they've got a lot in stock too, so that's a good sign. For connections, slide style, half pitch, fairly inexpensive and available on tape and reel. So this is my choice for the great search. Very useful. You'll see this in a couple products.
That's your search.
Where in the world is that part I need? The great search with DigiKey.
All right. Thanks for joining us this week, everybody.
Okay.
We'll see everybody throughout the week. Lots of shows and more. Happy Mother's Day. We'll see everybody later.
Bye, everybody.